Welcome to doassignment-ca. Here is the problem. A horizontal force acting on a 20-kilogram block has a magnitude that varies with position s according to F equals 50 times the square root of s in newtons. When s equals 0, the block is moving to the right at v sub 1 equals 6 meters per second. The coefficient of kinetic friction between the block and the surface is 0.3. Determine the distance s sub 2 the block must slide before its velocity reaches v sub 2 equals 15 meters per second. Now let's work through the solution step by step. We are given a 20-kilogram block pushed by a variable force F equal to 50 times the square root of s newtons. The block starts at s equals 0 with a velocity of 6 meters per second, and we need to find how far it travels to reach 15 meters per second. We will use the work-energy theorem, which states that the net work done on the block equals the change in its kinetic energy. Because the applied force is horizontal and the block does not accelerate vertically, the normal force equals the block's weight, 20 kilograms times 9.81 meters per second squared, giving 196.2 newtons. The kinetic friction force is then 0.3 times 196.2, which equals 58.86 newtons. Since friction opposes motion, it will do negative work on the block. The work done by the applied force is the integral from 0 to s sub 2 of 50 times the square root of s with respect to s. Integrating gives 50 times s to the 3/2 power divided by 3/2 evaluated from 0 to s sub 2. This simplifies to 100 over 3 times s sub 2 to the 3/2. The work done by friction is negative 58.86 times s sub 2 because the friction force is constant and acts opposite to the displacement. The change in kinetic energy is 1/2 times 20 times 15 squared minus 1/2 times 20 times 6 squared, which gives 2250 minus 360 equaling 1890 joules. Setting the total work by the applied force plus work by friction equal to the change in kinetic energy of 1890 joules gives 100 over 3 times s sub 2 to the 3/2 minus 58.86 times s sub 2 equals 1890. Rewriting the coefficient, this is 33.333 times s sub 2 to the 3/2 minus 58.86 times s sub 2 equals 1890. We solve this nonlinear equation numerically by testing values of s sub 2. At s equals 19 and 20, the function is negative. At s equals 21, it becomes positive. Narrowing down to s equals 20.5, the function is essentially 0 at negative 1.7. Verifying at s equals 20.5 meters, the work done by the applied force is approximately 3094.9 joules, and the work done by friction is negative 1206.6 joules. Their sum is about 1988 joules, which matches the required change in kinetic energy of 1990 joules to within rounding. Therefore, the block must travel approximately 20.5 meters to reach a velocity of 15 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.